mute out Anthony for a moment. All right, welcome everyone to the February edition of the PowerShell Virtual Chapter Pass. We're actually having two meetings this month, one today, one on the 15th. Super short intro for us today. Just go to the YouTube channel, sequelps.io/YouTube, if you want to see the recording of this session, and if you want to ask questions, you can do it in the chat or on sequelps.io/Slack if you have a big, long, complicated question. That is pretty much it. I hope Anthony is ready.
Howdy, everybody. Thanks for coming. Let's go ahead and get this all set up. This is a Linux operating system fundamentals for the SQL admin.
Oh, wait, one moment. It is still showing Aaron's. Okay, good. And just for the audience right now, they're testing tornado alarms in at Anthony's location, so that's going to be what you hear a little bit. Hopefully, we're hoping that it's not a real tornado.
Yeah, me too.
All right, it looks good. I can see the screen.
Okay, you see the regular presentation, not the notes, right?
Correct.
Thank you. See here that. So yeah, this is Linux operating system fundamentals for the SQL admin. I am Anthony Nocentino. I'm a consultant and trainer. I am the founder and president of Centino Systems, where I specialize in system architecture and performance. I've been in school for a very long time studying computer science, specifically spatial database systems. Recently named the data platform MVP. I'm still pinching myself over that one. There's my contact info, guys, so feel free to email me about anything today in the talk, or just SQL Server, Linux, PowerShell. I'd be happy to answer your questions. There's my Twitter handle. That's kind of my main way to get information out to the community, blog posts and whatnot. So go ahead and follow me on Twitter, please. The blog is at centinosystems.com/blog. Normally I blog pretty frequently and then build that into presentations. I have yet to blog about a lot of the topics in this presentation, but that will be forthcoming. I'm a Pluralsight author too, so a lot of the data that you guys are going to see today, there's much more deeper dives in the Pluralsight courses that I have. So if you want to really get into some of these topics more deeply, check those things out. So here's where we're going to go today, guys. And the way that I designed this presentation was to really kind of go over a lot of stuff, right, and give you some nuggets to go dive into. So we're really going to fly over a lot of different things. And we're going to start off with Linux architecture, right? We're going to look at the operating system and how it's constructed. And then we're going to learn how to interact with the system, right? Because that's what we do. We're administrators and we want to work with an environment. And then something that's familiar to you guys in a PowerShell sense, we're going to talk about the foundational technology, where it really came from in IO redirection and pipes from Unix pipelines. We're going to look at those and compare and contrast those with the object-based pipelines that you guys are used to. Then we'll get into some file system basics, right? Where stuff is on our file system. And I don't know if you guys know, but there is an open source version of PowerShell that is available now on Linux. And so we'll look at that and how that can kind of bridge the gap and get you guys over to the Linux world and supporting multi-platform data centers and whatnot. We'll talk about working with packages, right? Software on Linux systems is deployed in packages, and we'll learn how to install some software today. And then managing services, right? If we're administrators, chances are we're managing servers, and we'll learn about how to interact with systemd and manage services in a Linux system. We'll do some very high-level resource management, so we'll look at like CPU, disk, memory, and fun stuff like that, and then also where to look for help in your Linux system. So first and foremost, let's talk about the architecture of the Linux system, right? And like any other operating system, its sole function is to control hardware, right? Physical access to resources, things like CPU, disk, memory. And that's pretty much the sole function of an operating system. Now, higher up, you're going to have what's called the kernel, right? And the kernel is responsible for resource management and access, right? So you have higher level constructs of those underlying things, right? In hardware, you have things like processes, memory pages, file systems, files and inodes and things like that inside of the kernel. But we don't interact with the kernel. We interact with the shell, right? And so at a Linux system, just like you guys are familiar with PowerShell, is you enter commands at a shell, and that's going to be your interface to the kernel, right? You're going to enter a command to ask the operating system to do something. And in Unix, that bridge that goes between the shell and the kernel is called the system call interface. And we can kind of geek out a lot about that, but that's another topic. So, and the thing that we all do is, as users, we interact with the shell, right? And our sole function is to cause problems for ourselves and our user community, right? Not really. It's for administrators to fix those things. And just two terms I want to throw at you guys. There's kernel space, right? That's the stuff that's going on inside the kernel. And I'll show you a little bit later how to identify those things. And there's user space. And most of the time, we're going to be operating inside of user space. So interacting with your Linux system, right? There's two primary ways that we're going to interact with a Linux system. We're going to text, right? That's literally sitting at the console, or graphically, right? And so text interaction at the console, right? We literally sit down, keyboard, mouse, screen, maybe not mouse anymore, but, and also remotely via SSH. And the two primary ways in SSH is terminal, right? On Linux and Mac, there's a terminal program literally on each system, and then PuTTY is kind of the most common client interface to access remotely a Linux system over SSH. And then graphically, a little bit different than a Windows environment. There's a desktop manager, and there's a collection of desktop managers out there, GNOME, KDE, and whatnot. And then you can also access a Linux system remotely, graphically with VNC. Similar in Windows, but that's also available to you in Linux. So I do want to talk about access and privileged access, right? On Linux systems, security is based on user IDs, and the user that kind of care about the most, or not care about the most, but the administrative user, the most privileged access is root, and its user ID is 0. And so when you're sitting at your Linux system and you see this hash mark at the command prompt, that's a visual indicator that you're logged into the system with privileged access. And I do want to emphasize that you want to try to avoid using root, because root can do anything, right? In code inside of programs, literally you'll see, if user ID equals 0, do this, right? And that means unmitigated access to the operating environment. Now, on the other side of the fence is you want to log into your system and log in as a regular named user. And you'll get a visual indicator of that by looking at, you see the $sign at the command prompt. And of course, this is Linux, and those are standard conventions, right? You can make these things say anything. You're going to have the hash mark be a sad face, the $sign be a happy face, whatever it is, right? But this is where you're going to get by default in your bash shell. So kind of in that idea of avoiding using root is you need to be able to switch between users, right? Switch between regular users and privileged users. And there's two ways you can do that. Su and sudo, right? And su is short for switch user, right? So I type su and then a username, and I can switch to that destination user's security context, right? So if I'm logged in as demo and I type su demo1, I'm going to switch to the security context of demo1, that login ID. But when I do that, I'm going to use that user's password. And so if I type su with no parameters, it's going to switch me to the root user. And I have to type in the root user's password. And hopefully that's a really complicated password. It's hard to type, and I don't want to have to remember that. Now, on the other side of the fence, the way we can switch security contexts is with sudo. What sudo does, it allows you to execute an individual command with escalated privileges. And to do that, I could type something like sudo, and whatever that command is, and then hit enter, and it's going to ask me for my password, right? And so that's a good way to keep things separated. And also, one of the benefits of using sudo is that it's logged. One of the tricks I'll show you a little later is you can combine sudo with su and switch over to actual root access and then come back out. And I'll show you guys that in a little bit. So one of the things I want to show you guys is this quote. So Brian Kernighan and Rod Pike are kind of the forefathers of the Unix programming environment, right? They wrote the book, literally, on how Unix was architected, and the software was mostly written by these guys. So many Unix programs do quite trivial things in isolation, but when combined with other programs, become more useful and general tools. And let's kind of look at those constructs in this right here. So before we get to talking about pipelines, we have to understand inside of a Unix process, there's some special things going on. There are these file descriptors, right, that we can write to in memory that define the inputs and outputs of our process, right? And so file descriptor 0, standard in, is what we're going to interact with most when we're interacting with the process. Literally, if I were to type commands, it's going to go into file descriptor 0. Now, the output of a command is by default written to standard out, or file descriptor 1, and by default, that's going to go over to the terminal, right? There's also another file descriptor 2, which will write to for standard error. So if something's going wrong in my program, it's going to go to file descriptor 2. By default, it goes to terminal. But this is where it gets special, right? We can take these things and we can redirect them to other locations. So if I wanted to take all of my errors for a running process and run that data into a file, I can do that by redirecting file descriptor 2 or standard error to a file. I can do the same thing with file descriptor 1 for standard out. And I can even go so far as to take the input and pipe input from a a file into my process. So let's extend this into pipelines now, right, and how this all stitches together under the hood in what we call text-based pipelines. Like I said, you guys are familiar with object-based pipelines. So how does this all come together in the Unix environment? So let's say I have a command like ls, right? And inside of ls, I have all those file descriptors that I just talked about. Now, let's say it's a huge directory listing and it's going to run off the screen. So I'm going to use a command like more, and what more does is it'll read the input and display one page of output at a time. So I can smash a spacebar and get that second page of output. And what's happening under hood in a Linux system is that pipe, which you guys are so familiar with typing with in the object sense, literally connects the file descriptor, standard out, into the file descriptor of standard in on that destination process. And then it all pipes through and it goes out file descriptor 1 to the terminal to build my pipeline, right? And all that together is called a process group. Now, this is a reference slide. I know it's a lot of text, but I just kind of want to you guys can get into this a little bit more detail later. But if I am redirecting files, if I have a single greater than sign, right? If that file that I'm redirecting to doesn't exist, it'll be created, and if it does exist, it'll be overwritten. The double greater than sign, right? If it doesn't exist, it'll be created, and if it does exist, it'll be appended to. And that's a critical point there, so we don't smash over some data that we might be interested in. Let's jump down a little bit and look at standard error, and you can see 2 and then a greater than sign, and that's how I can pluck off an individual file descriptor to redirect that output to a file. So if I had, a process name, the number 2, the greater than sign, and then the destination of a file name, that's how I just literally take that one IO path out of the process. So let's talk about the Linux file system. And everything in Linux is a file, really, everything. What you're used to seeing is, files and directories, but it even extends so far as into devices, character devices, block devices. Processes are represented virtually in a file system so that you can go and interrogate them for information. So let's look at the basic file system tree inside of a Linux system. So at the root, right, you're going to have literally what's called root, and it's indicated by a slash. So let's walk through each of these directories real quick here on the right. Inside of bin, you're going to have binaries. Those are going to be locally installed system binaries. In var, which is short for variable, you're going to have data that changes very rapidly. So if you go look at in this place, you're going to see things like logs. SQL Server on Linux installs here by default, and so does MySQL or MariaDB. /home, each named user on a system should have a home directory. So here you see demo 1, demo 2, and so on. USR is going to be for locally installed programs, non-system binaries, and kind of extending that concept that everything is a file. Under /mount, you'll have remote file systems are conventionally mounted here. You can mount pretty much anything wherever you want, but conventionally you'll see things under /mount. And as sysadmins, we're probably going to spend most of our time the /etc directory. Inside of there, you'll find the configuration files for your system and most likely all of the applications and services that are running on your environment. This hierarchy here isn't just limited to Linux. It's Unix, and it's a standard. It's called the File System Hierarchy Standard. So if you go Google that, you can really geek out on how particularly each and every one of these things is defined. So one of the reasons I bring up PowerShell on Linux in this topic is I really want this to be able to bridge the gap for you guys, right? You're all probably PowerShell gurus and ninjas, and this is a good way to use PowerShell on Linux to bridge that gap to bring you guys over into the Linux environment. So I'm going to talk about PowerShell on Linux here for a second. So right now it's still in alpha. We all know what that means. But there is a roadmap for the beta and also the production release. I don't know if there's a timeline, but if you do go to the PowerShell project at GitHub, you can go and you can see the actual defined roadmap of what they want to bring into the full beta and in the full release for PowerShell on Linux. One of the things I have here is you can use PowerShell as your default shell, right? So if I log into a Linux system and I can change it from going straight into a bash shell to straight into a PowerShell shell. And if you follow that bit.ly link there, there's some directions for doing that. Now, one of the differences I want to call out for PowerShell on Linux is compared to Windows PowerShell, which you guys are probably used to, is that remoting works significantly different. It relies on SSH, right? And which means is if you want to manage, or if you want to use PowerShell remoting to manage a Linux system or a Windows system, all of those systems have to use SSH, right? The plumbing that literally moves the remoting session from Linux to any other operating system is SSH, and vice versa. If I want to remote from a Windows system back into a Linux system, SSH. So go ahead and follow that bit.ly link there if you want to get into how to configure remoting. It's kind of a fun exercise to go through. Now, one of the things I do want to call out is remoting in PowerShell and Linux works like legacy remoting does in Windows PowerShell. So you won't get parallel execution. So for example, in Windows PowerShell, the expectation is if I pipeline a collection of things into a command, that's going to post jobs asynchronously to all of the computers that I define, right? It doesn't work like that in remoting right now. You'll expect it to be a serial execution as it iterates over that set. But that WSMan or WinRM like remoting is coming to Linux, and it's on that roadmap that I was telling you guys about for the beta and the full release. One of the other big differences when you are using PowerShell on Linux is aliases, right? This is kind of a big one for me. So it depends on the operating environment that you're in. So if you're in Windows, right, and there's Unix-like commands that are aliased to the PowerShell command line. So here I call it specifically move, or MV, and I call it move item. And that's kind of what you guys are used to. But on the other side of the fence, if I'm coding in PowerShell on Linux or Mac, if I call move, the PowerShell team, and I think they made a good decision in doing this, they don't call move item. They just shell that back out to the operating system and call the native command under the hood, right? And how does that impact you guys? If I'm writing commands and I expect the output of one command as I pipe it into another command, you know, obviously on the Windows side, I'm going to expect an object, right? And on the Linux side, it's going to be a byte stream off of whatever that command is that I'm typing in my Linux operating system. So that can impact how when you're developing either scripts or whatnot as you're hacking away at the PowerShell. Now, if you do get lost, obviously you can use get alias to kind of spit out all the aliases that are available on your platform. So just a quick little reference for you guys where I kind of give you the file operations and directory operations. So on Linux, you can see touch, PowerShell, new items. So you guys can go through that when you have some time to talk about the basic file system commands to move around in a Linux system. So let's get into our first demo, and I'll show you guys how to connect to a system, which is pretty straightforward. And of course, like all PowerShell demos, I'm going to use get process to show you guys how to do some stuff, and then PS, which is the Unix analog to get process, and then we're going to talk about building some command pipelines. So let me go ahead and bring this up. Wrong VM. Well, that's going to be interesting. Give me a second to correct that, guys. Totally forgot to start the VM. Apologies.
No problem at all. I think I was just presenting in Vienna with Rob, and no, it was whenever I was in Vienna, Aaron was presenting as well, and it's not that he had forgotten his, it just didn't boot up properly, poor thing. Whenever he did go to start it, there was like an immediate crash. So I know it's always so stressful with that. If you would like, we could talk about the tornado.
I don't think there actually was a tornado, luckily. Right,
excellent.
Good shape here.
All righty.
Thank you. Get that out of the way. Demo. How's that look for you guys? Pretty good?
Really nice.
Thank you. All right, so what I'm going to do here is I'm going to SSH into a running VM on my system. I'm running on a Mac, which has a bash shell available to me. So I'm going to type the command SSH in the space, then the username at the server name, or in this case, an IP address. Go ahead and punch in my password. And here we're presented with a shell. One of the quick commands that I want to show you guys right off the bat is Control-L. If I hit Control-L, it clears my screen. It's sort of a luxury to have start off fresh. So in a Linux system, if I want to do the process list thing, I just type PS, right? It's going to spit out all of the active processes for my user. So it's a pretty small set. You can see my bash shell is running, and then obviously the PS command. But let's go ahead and kind of work up a nice example for a command pipeline here. So if I use PS minus AUX, that's going to list all user processes on my system. I get this huge kind of vomitorium of data that shoots across my screen. And it's a lot of stuff, right? Let's scroll up here. And lots and lots of things are running. So at the top, you can see there's some header stuff. User PID, percent CPU, percent memory. Virtual size is the actual virtual memory space, and resident set size is the actual amount of pages that are in memory for a process. So when you're looking at a command over here, anything that's not in brackets or braces is is a user process, and anything that's got brackets around it is a kernel process. Now, let's go ahead and kind of work up an example. I'm going to pull off the top 10 processes in my system. I'll show you how to do that in with the Unix pipeline. So simply enough, I'm going to take my output, I'm going to pipe it into sort, right? What that's going to do by default is it's going to sort it on, it's going to do an ASCII sort on the first column of data, which in this case is username, right? So I'm going to get root showing up first because of lowercase letters. At the bottom here, you can see I have some header data, right? I have user at the bottom. Not exactly a good representation of what's going on. So let's go ahead and figure out how to sort things a little more accurately to get our top 10 processes. To do that, I have to type sort minus nrk3. What is nrk3? Let's be serious. So let's walk through that. And this is one of the things, you know, after 20 years of using Unix, it's kind of just muscle memory. I have this built into my brain. But if you walk up to a system like this and you type, and you need to find out what the top 10 processes are, this can be a little bit overwhelming. So let's walk through each parameter. Minus n tells the system to sort numerically, right? Minus r is going to be reverse, right? Because I'm going to pull the top 10 most consuming processes. And then k is key, right? And so I'm going to look at the third column, which is CPU. So going from left to right, 1, 2, 3% CPU. Yeah, that was obvious, right, guys? So let's go ahead and pipe that into one more command, head. What head's going to do, it's going to pull off the first 10 things that it receives off of its standard in, right? And that's going to be the pipeline sorted values from RPS command. So you can see, again, still, this is kind of ugly, right? So I have PS minus AUX and all this fun stuff going across the screen, and now I have my top 10 processes. But if we go and look in here, no, it didn't make it into this input. One of the things I often have to do in this demo, I think just the circumstances worked out that the headers didn't show up, but you have to throw no headers in over here, and that'll strip off that header data. So there we have that command. Let's do the same thing in PowerShell. I've already gone through and installed PowerShell on Linux on this machine, but that information is all that's available online, pretty straightforward. Installing PowerShell on Linux is an RPM package. All right, so let's do the same thing. I'm going to fly through this because you guys certainly have done this one a million times. So get process, pipe sort object, descending CPU, select object. You can see I have tab complete here in PowerShell on Linux. First 10. All right, so I get this nice formatted output. Because one of the things that PowerShell does when it works with the output that it's coming in is the header data is not part of the output stream, right? It's its own thing, and then the data is fed into that under the hood. And so let's exit out of here and quickly do a compare and contrast between the Unix command to get the top 10 processes and the PowerShell command to get top 10 processes. One of these things is a lot easier to read than the other. I did a training video kind of towards the end of last year with Jeffrey Snover and Jason Helmick, and I did this same exact demo. And Jeffrey was looking at me, he's like, man, this guy's going to beat up on me doing this PowerShell stuff. And actually, I came to the conclusion, like, listen, if I'm walking up to a system, one of these commands is a lot easier to type than the other. And so I made the joke at the end of that session, pretty much I'm probably going to lose my Unix card after making that joke, that statement. So let's head back into the presentation here, guys. Let's move this over. Let's talk about installing software. On Linux systems, we install software, or let me be more specific with that. On Red Hat or CentOS-based systems, we install software with what are called RPM packages, right? So Red Hat, well, now it's called RPM package, actually it just means RPM for Red Hat Package Manager. And it's a package management system. But what's a package? A package is a collection of programs, scripts, and metadata about that package that we can install, upgrade, or remove on our system, right? And that RPM provides a suite of management tools for us to do that. But the one thing that RPM doesn't provide is dependency management. So if I type RPM minus I, package A, and package A requires package B, pretty much what RPM is going to do is going to say, hey, you need to install package B, and fail, right? So I need a better way to do that. Now, I do want to call out that I'm kind of a Red Hat CentOS-oriented person, and all the constructs I'm going to talk about when it comes to package management are available in apt in the Debian Ubuntu world. Now, what you're going to use most often probably to install software is yum. And yum is also a package manager, but it provides dependency management. So if I say yum install package A, what it's going to do is realize from the package metadata that it needs package B. And it's going to reach out to what's called a repository, download package B, install package B, and then install package A. Super convenient. So I used the word a second ago that I didn't quite define yet. It's a repository. What a repository is a collection of software that we can download and install those things from. And you're going to get those things from either your software publisher like Red Hat or CentOS or any of the other distributions that are out there. But there's also third-party Yum repositories that are available, specifically EPEL, or the extra packages for enterprise Linux, and RPM Forge. The common use case where I want to bring in a third-party repository. Well, first off, if you install SQL Server on Linux, that's going to be a third-party repository. But sometimes what will happen is Red Hat kind of lag behind with the version of software that it has available in its base repository, right? And so the primary use case for this was a couple years ago, MySQL. The version that was released by the MySQL team was probably a couple dot versions ahead of what was available in the base repository. And so what the community did is they packaged up the latest version of MySQL and it was available in a third-party repository for you to download. Another common use case when it comes to repositories is building your own. There's a couple benefits of doing this. One, you can publish your own software, but I think more common than that is having your own repository within your data center, right? So you might not have internet access, or you might not want to have all of your servers reaching out to the internet and bombarding your internet connection to download updates and other packages. So you can set up your own repository, point your servers towards that, and download information locally. One of the other benefits that Yum really provides is system-wide updates. I can type Yum update, hit the enter key, and it's going to update all the packages on my system. And again, all the constructs in Yum that we're talking about right now are available in apt on Debian and Ubuntu-like systems. So let's go ahead and do a quick demo of package management with Yum, and of course we're going to install SQL Server on Linux. So let's go ahead and move this out of the way here. Bring this back up. Control L to get a nice new console, and I want to copy and paste some commands so I don't have to brutally type things in front of you guys. So I'm going to use sudo, kind of that trick that I told you about earlier. Sudo su, then a minus sign, right? What that's going to do is going to execute the sudo command with my account, but the command that I want to execute with escalated privileges is su, which is going to switch me into the root user since I'm not defining a username. What that minus sign does there is it loads root's bash profile, so the commands and executables that I'll have available to me in my command path will be root's commands, not my user demos commands. And the password that I'm going to type right there is my password. And you can see the hash mark. It indicates that I have escalated privileges. So let's go ahead and paste this command in here. And what we have here is the command curl. What curl is going to do, it's going to download this file from Microsoft. Inside this file, you see mssql-server.repo. It's going to redirect the output of curl into the directory etc. Sorry, it runs off the screen there. yum.repos.d, and it's going to write that into a file, mssql-server.repo. Let's go ahead and hit enter. So that file comes down and it's redirected into, let's see, it's going to be yum.d or yum.repos.d, mssql server. And so what I just did is I added a third-party repository. Straightforward as that. You just simply put a text file in that special directory inside of our etc directory. So inside the repo inside this repo file is the definition for the repo. So here's the configuration name. This is the actual Yum repository name. And now where the data is coming from, right? The base URL. In this case, it's going to be an HTTPS source, right? And those packages will be downloaded over the internet. This can be an internal source. This can be a remote file system. This can be many different things where it's going to source those packages from. We have the ability to turn repos off and on. And really fundamental to using third-party repositories is this concept of a GPG check, right? That basically says that remote repository that I'm getting software from is that actual repository. You can see why that would be valuable because we don't want to point to the wrong repository, maybe like a DNS hijacking attack, and potentially download bad packages from someone that we don't know. So let's go ahead and type exit to get out of root. And you can see I'm back here at a regular shell for my user demo with that $sign. And right now I'm going to go ahead and I'm going to type sudo yum install. I'm going to throw a -y on there. And what that's going to do is when it gets to the end of this command, it's going to automatically answer yes to the yes, no, continue option that I want to get. And the package that I want to install is obviously going to be mssql -server. Let's go ahead and hit enter. And what it's doing right now is it's going out and it's updating all the package metadata, right? It's reading off the base repository. You can see I have EPEL configured here. There's the extra packages that are available from Red Hat themselves. And then obviously the repo that we just configured, the Microsoft repository. So now it's literally going out and it's downloading SQL Server on Linux and installing that on my system. And while it's doing that, it's going to break back into the presentation, and we'll come back to this installation in a minute. Let's bring this back over here. So managing services with systemd. So if we're sysadmins, one of the most common things we have to do is make sure that our services are up, running, and healthy and configured. And as PowerShell people, you're used to get service, stop service, restart service, those things. And if you're not quite in the PowerShell club yet, you're using services.msc and the graphical interface to start and stop your services and things like that. On a Linux platform, you're going to have what's called systemd. And systemd is overarching architecture that manages not just services, we're going to talk a lot about services right now, but really manages the whole state of your system, right? And so the managed services, we use this command called systemctl. And what systemctl can do is it can tell us things like, are our services running? Are they not running? It can give us the ability to start, stop, or enable or disable those things. Now, systemd defines these things called units, right? And what a unit is, it's kind of an abstract representation of a system resource. And we're going to focus a lot on what's called the system unit, but there's many other types of units. There's timers, devices, file systems, mount points. All of those things are available as units, and they're configured in what are called unit files, right? And like I said, we're going to focus a lot on the service unit today. So inside of the unit file for a service, we can define things like dependencies, so before and after, right? I need this thing started before I start this service. I'm going to show you that in a second. One of the other critical things that systemd does, and what we're going to look at too, is it provides what's called a journal, right? And a journal is a destination for log on our system, right? Conventionally, all the logs on Linux systems are going to be available in /var/log. What journald does is it provides a way to sync all of the logs from the processes that are communicating with journald and gives it a nice, compact, binary searchable interface into that journal. And to get into those logs, we use journalctl. So let's go ahead and jump back into the demo again, and we're going to look at how to start and stop and enable and disable things using systemctl. So we can see our SQL Server on Linux installation here is now complete. Let's kind of do it a favor and finish the installation as requested. So I'll type sudo. I'm going to run the setup script. Of course, we agree to the license. Give it a password. And get that all going. And right here it's asking me, do I want to start the SQL service now? No, because I want to show you guys how to do this manually, right? And so the first thing I want to show you guys to do is, what we don't know right now is we know we've installed SQL Server. We don't know how exactly to find which service we want to interact with SQL Server, right? How do we know like which commands to type and what that unit name is? And so to figure out what's going on is we can type sudo systemctl, and we use this command list unit files. Go ahead and press enter, and you can see what it gives me is a pager interface to all of the registered units on my system, right? So I can see the unit, its name, and then a type. So I can see cups.path, right? Scroll down a little bit. I can see anaconda.direct.service. And so on the left-hand side is the name of the service. On the right is the unit type, so .service. And so if we're paging through this, we're obviously looking for something like SQL Server, but that can be kind of challenging to do. Here we go right here, MSSQL-server. But I don't want to have to do that every time I want to look for something. So I'm going to ask the shell to make this a little bit easier for me. So I can do the output of systemctl, the unit files, get all the units that are running on the system, not just services. And I'm going to pipe that to a command called grep. What grep does, it'll search for patterns in the text, right? So that output that's coming off of systemctl, I'm going to feed that into grep. And I'm going to tell grep to ignore case. Just I do that by default, is just ignore case. I'll do grep -I to ignore case, because Linux and Unix is a case-sensitive environment. And I'm going to look for something like SQL. And so there I get a much smaller list, right? I can very quickly identify which services are part that I want to start interacting with systemd. So right now we can see that it's disabled. So let's go ahead and enable it. So we can do that with sudo systemctl enable MSSQL, not MySQL, wrong demo. MSSQL-server, and I can use tab complete there to autocomplete that. I was trying to get that going. So one of the things that you can see is it created this link, right? So under the hood, systemd uses unit files, right? And that unit file is linked into a special directory that defines what's called a target. And a target is a collection of units, right? And so here you can see what's called the multi-user target. What the multi-user target is the collection of services that define a multi-user system. And so what we just did right here is we told systemd that MSSQL is part of what's called the multi-user target, which is my default target. So when my machine starts up now, it's going to load to what's called the multi-user target, and now it's going to include SQL Server in doing that. It's going to do one more thing, systemctl. So I didn't do yet, systemctl, status, MSSQL-server. So this is the default output when I want to ask systemd for the status of a unit, right? And the output here can be a little bit intimidating. So let's kind of walk through it. So this is simply the service name. So we see MSSQL-server.service and then some text that defines what that is, and it's the database engine, right? So loaded here, what loaded means is that systemctl knows about this unit. It's a registered unit, and where it's reading that unit file from is here. You can see it's usrlib systemd system MSSQL-service or .service. And we just enabled it a second ago, but if it was disabled, you'd see that right there. Now active, right? It says inactive. What this means is that this service is not up and running. At the bottom here, we have some output. This output here is the last 10 records for this particular service unit that's in the journal. There's only 2 records here right now. We'll change that here in a second. So let's go and use the up arrow, which can bring back the previous command I typed. Type start MSSQL-server. It's got to press enter, and we get no output, which I think is kind of weird. I much prefer to have it put the output to the screen. We'll use the up arrow again to call systemctl status MSSQL-server. Now we got a lot more output to go through. Status start. Yep, we're okay. We're good. So again, same stuff at the top here. It's a little introductory stuff. It's still loaded, but now we have active running, right? So it indicates that the service is now up and running. It's up and running since about 10 seconds ago, right? So it's a good way to very quickly determine, is the service up and running, how long it's been running for. So here we can see the main PID, right? So the process ID is 3367, and the binary that it loaded was SQL Server. So here we see there's two user tasks that are running, right? There's the main process on 3366 and also another one on 3371. These processes are aggregated under what's called a control group, right? This gets kind of cool. So what a control group is that it allows me to apply policy to the things in that group. So here we see system.slice MSSQL-service. So if I wanted to apply a policy to this service, I can do things like limit the number of disk IOs that this thing can do, or I can adjust the scheduling priority that SQL Server has access to the system, or even the amount of memory that it has access to. So independent of what's going on inside of the instance, I can apply these policies at the operating system level. So now we have the last 10 entries from the journal D, right? And so we can see a timestamp, the server that posted the journal D, the process name, the process ID, and then the actual entry in the journal. And this stuff that you're going to see here in a second is going to look very familiar to you guys. You can see it kind of wrapped some of the output by putting some ellipses there, so it just filled one line. I'm going to throw the -L to get the full output. And it doesn't look exactly great on the screen, but this is the SQL Server error log, right? And so what the product team did is they decided not only are they going to write the error log inside of SQL Server, but it's going to come out of SQL Server into the operating system and store that data inside of journal D, right? So these are all the things that you're used to seeing when SQL Server starts up. Okay, let's go ahead and switch back into the presentation. And talk about system resource management. So like all computer systems, right, we care about things like CPU, disk, memory, and networking, right? Kind of the core resources when it comes to the resource consumption in our environment. So I'm going to kind of walk you through the things that we're interested in, and I'm going to show you some commands where you can get this data from. So when it comes to CPU utilization on Linux systems, we can measure percent CPU. But I like to focus a little more on the thing called load average. And what a load average is is the length of the run queue for threads or tasks that want to have access to the CPU, right? If I start seeing that queue grow, I know that my CPU is either saturated or my threads or my processes are waiting on something else. And so as those queues get bigger, that can be an indication of a performance issue. And so whenever you look at percent CPU utilization on a Linux system, right next to that is going to be the load average. And you'll see it in 1, 5, and 15-minute increments. From a disk standpoint, clearly we care about space, right? I'll show you some commands about that in a second. And obviously latency, right? One of the things that's interesting about how the Linux kernel tracks latency is it doesn't really deal well with the latest and greatest drives. There's things like NVMe that dispatch parallel IOs. The kernel level accounting isn't exactly accurate when it comes to tracking IO latency for parallel IOs. Serial IOs, that's okay. But what we really kind of want to focus on are IO weights. And the commands top and a couple other commands I'll show you will tell us, how much percentage am I spending waiting on IO per process. Memory, so clearly we care about memory pressure, right? Am I running out of memory? Am I swapping, right? From a database perspective, or even any server perspective, if I'm swapping, my users are suffering. Networking, so clearly we're going to care about throughput, latency, and reliability, right? There are things falling down from a networking standpoint. We also have access to the SQL Server DMVs, right? So inside of SQL Server on Linux, if I am looking for things from a performance standpoint, a lot of the data that we're used to getting out of the DMVs is available. So I did some tests earlier this week with the DM virtual file stats where I was putting a lot of IO pressure and measuring the latency. Those numbers seem to be congruent with the capacity of the hardware that I have. So again, that's kind of some preliminary stuff, but those numbers look pretty good. So here's some of the tools that we have available to us in Linux, right, to get resource information out of our environment. So we have top, which is going to give us CPU information. VMstat, which is going to give us information on swapping, right? Am I swapping things out to disk? Free gives us total available and consumed memory, and also file system memory that's allocated to the file system cache. By default, that comes out in bytes. Throw -m on there, and you'll at least get it in megabytes. If I want to get the disk size for a particular directory, I can use the command du -csh, and that'll give me that output in megabytes. df-h will give me the disk utilization for an individual drive. And one of the programs that I'm a big fan of is a program called dstat, but this one's actually not included by default when you install a system. The rest of these on the top half of the list are. But dstat's kind of like your monitoring Swiss Army knife. And I guess it's analogous to perfmon in the sense that I can use dstat to go and query periodically information out of, or performance data out of my Linux environment for all of these things, CPU, disk, memory, and networking. And what's cool about dstat is I can tell it to redirect its output to CSV, and then I can scoop that data up, throw it into a spreadsheet program, and start doing some trending and analysis or load testing. SAR, or the System Activity Reporter, what that does under the hood is that goes through and it collects periodic data and stores that in a binary file locally on your system and generates reports for you daily. But you can also query it and ask it, hey, what happened when, right? So if a user calls you and things were slow 2 days ago, you can start doing your forensic performance investigation with the data that it recorded. So it's a very, very valuable tool. So let's kind of make some connections for you guys with regards to what you see in the Windows side of the house and what you can see in the Linux side of the house. So we have here is if I'm going to look for CPU utilization on my system, and I'm looking at the Windows perfmon counter, I have percent processor time. On Linux, kind of the main program to use is top, and it's going to give me percent usage, load average, and a bunch of other data. Memory, right? You're used to looking for percent bytes or percent committed bytes in use, free -m. It's total used free space and things that are dedicated to the file system cache. Disk space, right? I'm going to pull that off with df-h. IOs, right? That's a big one for us as DBAs. We're used to looking for disk transfers per second out of the perfmon counters. We can use IOstat -dx, and that's going to get us transactions per second, which is read and writes, or reads per second or writes per second. So we can kind of differentiate between what IOs are occurring. If we're looking for average disk, or we look for disk latency, we average the seconds per transfer, IO -dx, and service time, right? SVCTM, I throw some asterisks on there because that's kind of that nuance that I was telling you guys about earlier when it comes to measuring disk latency. IO size, right? It's another thing that we care about as DBAs, is how big are our IOs, so disk bytes per transfer, I can pull that out at the same command, Aiyo stat minus dx, and here you can see average request size. And then finally, we care about how much network consumption is going on, right? Bytes per second coming out of the Windows perf mount counter, which I think is kind of funny because I don't know a network engineer on the planet that measures throughput in bytes. But the Linux tools, there's a whole slew of them available. IFStat and BWMMG and endload are kind of the main ones that people use for measuring throughput. My favorite over the years has always been BWMMG, which is short for bandwidth monitored next generation. So things like packets and bits per second will come out of that. But like I said a second ago, all of this stuff can be queried out of DStat. If you really want to use one tool and want to start in one place, that's probably a good place to start. So getting help. Inside of a Linux system, you could have what's called the man pages. And anything that's installed in your system will likely have a man page entry. So you type man, and then that command name, and you'll get the interface, or all the description of what's going on for that particular program that you want to work with. You probably could literally get by with just that. So if you get really good at cruising to man pages, you stop Googling first for your answers. Obviously in PowerShell, we have get help, so that's kind of something that you guys have been used to. On Red Hat-based systems, we have local documentation in USR shared doc. So anything that's installed in your system will dump its reference documentation in this directory. So you'll find things in there like help files or README files, and also example configurations, and more importantly, default configurations, right? If you jam something up in one of the configuration files in your /etc directory, and you need to figure out what you had, maybe you don't have a backup, it's a good place to look.
Hey, Anthony, we lost the audio. At least I did. Hope I'm not cutting you off. Oh man, I don't even have any Taylor Swift to play while we wait. This has never happened before. So I'm just going to awkwardly talk to myself.
IO redirection and text-based pipelines and making that connection
There we go.
back to, what's that? Oh, object-based pipelines. Kind of walked you through some file system basics, and and using PowerShell and Linux to kind of bridge that gap for you guys to bring you over into the Linux world. Installing packages, how to manage services with systemd, and system resource management. So again, each and every one of these bullets can be a course on its own, but I'm trying to give you guys kind of a broad spectrum of where to look at when you get started in a Linux system. These are those Pluralsight courses I was telling you about, where I dive into a lot of detail about all these various attributes of this talk. So if you want to dive in on how to install or how to do some really cool performance monitoring, all that stuff is available for you guys there. I'm going to give this deck to the user group, but it's also going to be available on my website if you guys are interested. I'll put that up there probably later today. So, are there any questions?
We actually have quite a number of questions. Let's see. Is everybody ready to begin? We did lose you there for a second, and so I had jumped in, which is why you kind of heard me talking. But then you came back. It was only about 20 seconds or so. I sang some Taylor Swift for everyone, and it worked out well. So, okay. So
was it the blank space?
I love that one. It was Style from 1989. Okay. So let's see. Going through. So they were asking about the PowerShell channel. They want to know where they can find the presentation file. So the presentation, the demo, the sample, the code, and all of that. Will you be providing that to us? We do generally email the speakers. So if you're up for it, then you can just email us back.
Yeah, absolutely. Anyone can contact me directly if they want to, and I'll give you guys, I'll PDF the deck for you guys for your website. And the demos, I don't have them scripted out, but I'll type something up like a README file to kind of walk through the things that I did today for you guys.
That'd be super awesome. What's your Twitter handle so that people can contact you on Twitter?
So it's just my last name, so it's @Nocentino. If you want to hit me out there. Am I still presenting by chance?
Yes, you are. Oh, wait, are you presenting your screen? Hold on 1 second. Yes. Oh, there. Oh my God. I'm so sorry. That was me. I was actually looking at the Slack channel, and it was covering this. Okay. Sorry, guys. All right. Let's see. Oh, somebody wanted to know how you can install PowerShell on Ubuntu.
So let's go ahead and show you guys how to do that.
A very nice response. You're just going to demo it? What?
I don't have an Ubuntu system to show you, but I know exactly where the documentation is.
Awesome, cool.
So if you go to GitHub, the PowerShell team has, well, everything here. And if you scroll down, right here you have the packages and the instructions to install PowerShell on any of the various environments. I want to emphasize this is the alpha version of PowerShell 6, right? So it's not production code, nor is it the stuff that you expect that you see in PowerShell 5 or even the latest iterations of PowerShell 5. So right here you can see Ubuntu 16.04, the instructions, and it shows you how to do that right here. So yeah, I kind of jumped over installing PowerShell today, but this is where you do that. So there's the CentOS one right there if you're using that, or even Mac OS if you use Mac. So
Cool.
which is kind of cool. Yeah.
I didn't even know this. I have a terrible confession. I have not, even though I'm a huge fan of Linux and I use OS X primarily. I have not. I've installed SQL Server on Linux, but I have not installed PowerShell, and I probably shouldn't be saying that out loud, but I will anyway, because there's only
So
117 of us here.
yeah. So obviously, so right here I have PowerShell on my Mac, and this is kind of one of my go-to things in my tool belt when I need to do something. I would like a lot of stuff that we normally do in PowerShell. Mostly it's stuff that I'm doing locally, manipulating text, slinging things around, objects like that.
Yeah.
But yeah, it's definitely a new tool in my tool belt.
I'm gonna have to try it one day. So let's see.
Super easy.
I had answered this question. I'd be curious as to your response. Somebody said, just a quick question: is SSH something similar to RDP? What we do in the Windows world? And I said that exporting your X Windows display would be closer to RDP. SSH is closer to Enter PS Session, and then there's also good old VNC. Do you have anything else that you'd wanted to add to that?
No, that's a pretty good way to represent that. So yeah, so SSH is going to give you a remote text console, but it also can be used as plumbing, like the PowerShell is using it to move. I do believe that when you are using PowerShell remoting, they're using SSH just as a communication pipeline, and they're putting data into the one end of the pipe, and it's popping out of the other end of the pipe into the PowerShell subsystem. Let me show you guys that.
Can you copy files using that? That would be amazing.
No, that was one of the things when I was like, yeah, I was doing that training video with Jeffrey Storm. Hey, listen, when's that happening? Because that's really cool.
Totally.
But you can copy files. You can copy files with SSH. Let me show you. So in Etsy, right? We're talking about all the configuration files for your system are going to be in Etsy. So SSH is, or the SSHD_config is the configuration for my SSH daemon, right? So inside of there, permission denied. Breakout. Oh, here's one trick. This is like a big one. So if I'm at a command prompt and I'm at the end, so you can see my cursor kind of dangling at the end here, Control A, beginning of the line. I don't have to sit there and mash the left key until I get all the way to the end. And then when I'm done, if I want to, Control E brings me back to the end of the line.
Yeah, I've been doing it wrong all these years.
Man, when someone showed me that for the first time, I gave him a big hug. I was like, thank you. You've changed my life.
That is hug-worthy.
All right, so this is some deep dive. It's not configured. I snapshotted my VM and I rolled it back. Never mind. But basically, PowerShell is using SSH as a communication pipeline. So right here, what we'd see under the subsystem is we'd reference the PowerShell subsystem. We define it, and on this end of the pipeline, what happens is the data that's fed over SSH via PowerShell remoting is going to get to this call the subsystem, which will name PowerShell. So that, imagine it said PowerShell right here, and it would call the PowerShell binary locally. And so that's how remoting works, is over SSH, where the processes are using SSH to send, I believe it's XML documents back and forth to each other for commands, execution, and then output, I believe. But it's it's kind of hard to sniff when it's over SSH.
So cool. Thank you. One of my favorite questions is to run the systemctl command. Is it mandatory to run it with sudo user?
The reason why I do that is for some of when I'm doing status, so systemctl status server. Wait a second. All right. I did it with sudo today because one of the times I did it, I got no journal D output at the bottom here, but clearly it's did it right now, and I'm a regular user, so I'm gonna have to investigate that a little bit further.
So it does work
So
with
clearly, I
regular
did it.
users?
Yeah.
Yeah. My favorite distro is SUSE Linux. I don't even know how to say it, and we
That's
haven't
right.
used we haven't really used System CTL, or maybe we have, but like I'm such a barbarian at the command line. I'm just like whacking out at C, get it to work, and don't tell anybody. But then I'm just confessing all these things. Whenever, because my lab is just, yeah, you just replace it with a snapshot, right? And so since I overwrite
Mhm.
stuff, I just do sudo -s, and I just have a sudo shell where I do everything, which is why
Mhm.
I don't really know if you need sudo to do the CTL, because I'm just always in it anyway. I don't have time. I don't have
Yeah,
time
it
to
gets
type
to
my
the.
password.
Yeah, I mean, it gets to the. Well, it'll cache it for you. So if you do,
5 minutes or something.
yeah,
Not long enough.
yeah,
And
and
I
then
want
if
to
you
come
want,
back hours later and still just, be in that root shell. That's how I
I
roll.
think it's configurable. And if you want to blow out that cache in the event that you are concerned, like you want to get rid of the sudo privilege or
Oh,
the cached sudo privilege, sudo minus k does
oh,
that for you.
very cool. I did not know. Somebody said, "Hey, thanks for the intro to Linux, PowerShell, and SQL Server on Linux." They're super excited. And another person asked, let's see. They said in Windows we have Active Directory to manage users. In
Mhm.
Linux, oh, let's see if oh yeah, do we have the same concept?
Meaning like, I have a centralized user database. Yeah, that we're
Probably.
kind of
Yeah,
okay.
I'm imagining that they're asking about LDAP.
So I should I tell? Yeah, I'm gonna tell a story. So I worked at a university for a long time, and I was the network administrator for the computer science department, which was like the coolest job ever because I was like the computer nerd, right? And one of the first things that I did is I set up centralized authentication, right? Because everyone's running all these Unix systems and have local accounts, and it was making me crazy from a security standpoint. And so what I did is I set up AD, right? Because I could have done it in Unix. I could have set up an LDAP server, defined all my users. I could have set up Kerberos for ticketing and
Boo,
authentication, all that fun
boo.
stuff, right? But I could have just typed DC promo and I'd have all that functionality coming out of a tightly configured Windows interface, right? Again, of course, I could do it the other way, but I was trying to solve a pretty nasty problem very fast. So when Linux systems, you have what's called PAM, or pluggable authentication modules, right? And so I can do two things. One, I can tell PAM to authenticate my users against this particular Kerberos server, but I can also tell my Unix user subsystem to look for my users from a particular server, right? So I can do something like, show you guys. So my highest user ID here looks like it's 1001, right? I can tell my Unix subsystem for authentication that says any user ID over 2000, go look at this other server, right? And what I did in that circumstance is that other server was Active Directory, right? And so if I wanted to authenticate for my system, I logged in and Unix saw that my user ID was above 2000, it'd go hit up AD for my account, and then it challenged me for credentials, hit up AD for the Kerberos auth, and then I'd get into my system, right? So I
Super
can
nice.
use AD to authenticate. Yeah, totally.
So yeah, back in 1997, I was going to school in California, and we had labs that mixed Windows and AIX, and I thought it was the most
Mm-hmm.
magical thing ever. And integration like that is one of my favorites as well. If you the people in the audience, if you go to netnerds.net, that's my blog. If you type in Linux SQL, I actually have a lot of posts that talk about SQL Server on Linux, but also just using the client. You can log into Linux with the client, and then use Windows authentication or Kerberos to connect to a remote SQL server. So before they came out with the SQL Server server on Linux, they had the SQL Server client tools and ODBC, and it came with BCP and SQL CMD. And so I had spent some time exploring that. So if y'all are interested in seeing how all of that works together, you could just look at that.
Yeah, from a SQL Server on Linux standpoint, I don't know where they're heading. I think I don't know where the product team's heading with the. Certainly, they're going to have it, right? To have
The
Windows
Windows
authentication
authentication.
in SQL Server on Linux.
It was something
Yeah,
that I know that they were interested in, and I don't know if it's yeah. I think that it's something that they would like, and I don't know where they're at with it. That would be super amazing. I think that once that
yeah, I think so.
happens, that's whenever I'll start considering it. Because until then, yeah, I don't like the whole SQL thing.
You guys know Ryan Adams, right?
Show enough.
He did a blog post last March that kind of shows you some plumbing on how to set up Samba-based Linux authentication. A little bit different of a nuance than what we're talking about, but this is step by step how to get uh, Samba servers to authenticate against Windows systems. So if you want to kind of get into there, this is using AD as its backend. So it's another way. Like it's one of the things with Linux. It's just like 10 different ways to deal with things,
Totally.
right?
Yeah.
Yeah. But when I did the integration I told you guys about at the university, that was kind of the concept. Is I wanted to use like standard technologies, and in Microsoft in AD, the plumbing underneath AD is Kerberos and
Right.
LDAP NIS. So
I'm trying to find, I think if you say using Windows authentication, let's see, that was written, Ryan wrote that one in last year. And I recall either I wrote a follow up soon after, but if you search for Windows authentication and SQL Server, I do have, it's one of my favorite things. Um, and yeah, dude, I even got like I had what was it? It was something ridiculous. Bash on Windows on something, and I ended up using Apache. It was a
mhm.
ton of fun. Um, I thought that I had. I wish that I had the link real quick.
So
Joining
I have it up here on
Ubuntu.
the screen right now. Your blog post.
Yeah. Oh, I also have one called Joining Ubuntu to an Active Directory domain, and that one does use a little bit of Samba, kind of. And it's I always try to keep it as like short and concise as possible. And with this post, I really try to dig so that I think that one of the things about PowerShell and Linux is that it's scary to people who are just starting out, and so I tried
Mm-hmm.
to make it as approachable as possible.
Mm-hmm. Yeah, I think one of the reasons, and that's why I brought up PowerShell Linux in this talk, is because if everyone here is a PowerShell guru, they can use that as a stepping stone to bring them over into the Linux router. Because all those commandlets that you're used to, a lot of
Totally.
those are available. Yeah,
Right.
and they're not all there. Like one of the ones that I really want is clearly like managing services with systemctl, and there's no crossover to PowerShell yet. Like I start service, stop service,
Yeah.
restart
Yeah.
service.
Yeah.
I'd
Yeah.
like for that to interface with systemctl, and there's a C library that can be imported. You can write the code against that. I mean, if I had all the time in the world, I'd pull that off. But
No.
that's one of the things that can happen. The PowerShell team does have in their demos, um, they have a systemd uh, commandlet that they wrote. Sorry, my brain totally froze right there. But all they're doing under the hood is where's it? Maybe it's not this one.
While you look, I could sing you praises. Everybody's really excited, saying like this was a super great
Cool.
presentation. The mapping of from Windows counters and Linux commands was a great touch, and thanks so much.
Thank you.
Good presentation, great session. Everybody has enjoyed it. And then someone was asking, is there documentation to show more mapping of PowerShell commands with Unix commands?
That's a good question. Because no, I guess we could. Let me finish this thought.
Yeah, totally.
This is the kind of intermediate step to using this is journal CTL, but intermediate step to interacting with systemd is building a function around it and feeding that back as command. So that's one way to handle that because it could just take the output. The mapping stuff, no, but it's probably pretty easy to do because if I can go to the Linux side or the Windows side to get alias and anything that looks Linuxy to me, which I could just identify by memory
Yeah.
and just call that out. But I guess you could dump them and like compare to text files, right? Something
Yeah.
like that.
I think, I remember there being, it's possible that somebody had already created a guide. That sounds familiar. It was something like PowerShell for the Linux admin. that mapped them, but I don't know if it went the other way. You know, if you're used to it in PowerShell, um,
Mhm.
can you do it in that? But I
There's
would
a
go on. Sorry.
yeah. Oh, sorry. For the grep stuff that I was doing, I showed you guys grep. Someone took the time to do a one-to-one mapping of advanced grep searching back to, I think it's select string that the PowerShell side uses,
Yeah.
and feeding that and so there's a one-to-one mapping for that for doing text pattern searching.
Awesome. Is it built in? Is it native, or is that an additional command from someone else?
No, it's built in. So if we did
Super nice.
PowerShell, let's see, awkward takes us
No,
above
ridiculous.
select string.
Man, people
Um,
just they really love. Oh, okay, it came up.
Yeah, so there you go. So you can do simple match, and then what's the other one for the advanced match? All right,
Very
pattern. There it is.
nice.
So yeah.
Someone asked if
Well,
you
cool.
need
Is
to
there any other
install, yeah, .NET on Linux for PowerShell to work.
.NET? No, it's actually native. Wait, can you repeat the question one more time? I was
Do
answering it.
you need to install .NET on Linux for PowerShell to work?
No. The only thing that you need to install is the PowerShell package. So grab PowerShell. So you can see I have PowerShell installed. Now let's do QL PowerShell.
Ooh,
So
okay.
here's all like these are. So let me show you that command before I get too far. So RPM query can query the RPM package subsystem, right? To feed out the metadata about a package. So when I install something, all that stuff gets registered in a database. Now RPM minus QL, it's going to query that database and it's going to list all the files that are inside that package that got installed, right? And I'm looking for PowerShell, and then I'm piping it to more because it's going to run off the screen really fast. So all of that stuff is for PowerShell and Linux is PowerShell and Linux is self-contained, right? So you can see in /opt Microsoft PowerShell, these are the program binaries that are PowerShell and Linux. And so you can go through and you can see all these different things.
What do you know? Oh, well, sorry. One quick thing. If you guys look at your questions, somebody actually pasted the link to the Git book, DevOps Collective, a Unix person's guide to PowerShell. So it seems like somebody does have an online book. So there are two links there. And
Cool.
the question I was going to ask you is, what do you know about .NET on Linux? Is there a .NET on Linux?
Yeah, so .NET Core is available for Linux, and it's also in GitHub as an open source package. So let's see, .NET Core Linux. So I did some monkeying around with this when I did a blog post about this last year, but you can get .NET Core and install that on your
Too
system.
cool,
That's all
huh?
available here.
So nice. I love where Microsoft is going with all of this. And
Yeah,
I'm also going to take a
because
screen. Oh, go on. Sorry.
uh, there's no smoke and mirrors on this. This is the code. So if you want to go and look at the plumbing of how PowerShell works or how .NET Core works, it's in here. It's not like there's not some masking things or importing libraries that we don't have access to. This is it right here.
I love the openness. I'm trying to take a screenshot. I know that you'd be really. Oh, there we go. There we go. All right, I got it. Finally. It's too many keys on Mac to take a screenshot. I just want my print screen to work. Of all the
Control
questions
Shift,
and
yeah.
yeah, that's too many. I'm already lost. All right, I think that that we'll be wrapping up now. Thank you everyone for joining, and thank you
Cool.
Anthony for such an amazing presentation. And I look forward to having you back in the future.
Awesome, guys. I appreciate the invite. Thank you very much.
Cool. Thank you guys. See y'all.